Hello my dear students, in today's video we are going to discuss the most important previous year questions from the chapter Semiconductors. Here comes the very first question. Identify the operation performed by the circuit here. So here you can see a logic circuit and we need to identify what is the operation which is being performed here. Okay. So just try to understand here. Here this is A going in. Okay, so if this is A, this one is also supposed to be A as well as this one is also supposed to be A. Okay, then it's an OR gate. It's an OR gate. Alright, so here this is supposed to be what? Again A only, and followed by a NOT gate. So it's going to be what? A bar. Alright, fine. Similarly, two more gates are here. Okay, two more gates are here. So here this is B going in. So it's going to be B out. Here this is C going in. So it's supposed to be C out. And I'm having that NOT gate here. So here the same thing, 3 NOT gates. Okay, so it's B bar and here this is C bar. Okay, all together coming in, and that is again getting into an OR gate. Okay, fine. So what it is now? Here this is A bar plus B bar plus C bar. Okay, and that is given as an input to a NOT gate. What it's now going to be? It's going to be A bar plus B bar plus C bar, the all complement, or A complement plus B complement plus C complement, the all complement. What it is supposed to be? Here this is supposed to be A dot B dot C. A dot B dot C, which is supposed to be an AND gate. I hope it was clear. Now let's move to the next, that is question number 2. In the following digital circuit, what will be the output at Z when the input at AB are 1 0 0 0 1 1 0 1? That's very important. Okay, the input sequence is very important. It is 1 0 0 0 1 1 0 1. Okay, so here let's redraw the circuit diagram, and based on that let us finally come to the truth table for this, and that will take us to the answer. Okay, so here this is A going in. Okay, and here I am having an AND gate followed by a NOT gate. Okay, so here this is A, fine, and I am having an OR gate here. That's OR gate. Now here this is the second input, and here this is the first input for the OR gate, and here this is B. Alright, so A is coming here, A is coming here, and B is going like this. Here this is B. Okay, fine. So here this is A going in, and here this is B. So here I can say that this is going to be C for me. So C is equal to what? A dot B, and here this is going to be what? C bar, because I am having a NOT gate here. And what is the condition here? Here I am going to have it as what? A plus B, because it's an OR gate. Okay, so now this will come, and let me mark this as what? D. Alright, so here I have got C bar and here I have got D. Now here this is D coming. Okay, now here what it was? This was C bar, so I have got that C bar here. Now these two are coming here like this, and I am having an AND gate. I am having an AND gate here. Now what this is? Here this is C bar. Okay, dot D. Okay, fine. And I must treat that as what? E. I must treat that as E. And now this C bar is extended here, and that is now given to an OR gate. That's given to an OR gate here, like this. So that OR gate is there. Now I can mark this as, so E is there and C bar is here. Now here this is supposed to be F. Okay, here this is supposed to be F. And what should be F? F should be C bar. Okay, this C bar plus E. Alright, and finally what I have? A NOT gate, which means the output should be F bar. Is that fine? Now I am going to create the final truth table. For that I have got, of course, A, B, and B is there. Now we are having what? First of all, we are having C. Okay, C, that's equal to A dot B. I am having C. Alright, then I am having what? C bar. Then I am having D, which is equal to A plus B. Okay, then I am having E, that is equal to what? That is equal to C dash dot D. Okay, that is E. Then I am having what? E plus C dash, and that is F, and the last one is inverse of that. Okay, so we will deal with that, no worries. Now, yes, the 4 input values, 1, 2, 3 and 4. Okay, fine. So here this is F. F is equal to E plus C bar, and the inverse of that is going to be the final answer. Now our input values, it was 1 0 0 0 1 1 0 1. All right, yes, our values are 1 0 0 0 1 1 0 1. Okay, first of all, it is A dot B. Okay, for A dot B, this is the only value which is supposed to be 1, and the rest all is supposed to be what? 0. Next is C bar. This is supposed to be 0, rest all supposed to be 1. Next is A plus B. For A plus B, this is supposed to be the only value which is going to be 0, and the rest all is what? 1. Okay, now it is C dot D dash. For C dot D dash, this is supposed to be 1, and this is supposed to be 1, and here this is what? 0. Alright, next is E plus C bar. Here this is C bar, okay, and here this is E. Okay, and here for that one, I am going to have this as what? This is going to be 1, and here this is going to be 1, this is going to be 0, and this is going to be 1. Now my final answer is going to be inverse of this. Okay, that means 0 0 1 0 0 0 1 0, which means option C must be correct answer for that, because I told you my final answer is going to be what? F bar. So 0 0 1 0, that means option C need to be the correct answer for this. I believe you got it right. Now let's move to the next, that is question number 3. Yes, the circuit shown in the figure below is working as an 8 volt DC regulated voltage source when 12 volt is used as an input. Okay, now the power dissipated in milliwatt in each diode is, considering both Zener diodes are identical. So the question says, I am having an input voltage of how much? 12 volt here. I am having an input voltage of 12 volt here, and the potential difference across this is maintained as 8 volt all the time. And I'm having two diodes here, Zener diodes. So across each, I'm going to have what? 4 volt each. Okay, I'm going to have what? 4 volt each. So altogether 8 is getting dropped over here out of 12. So how much is left? We are left with 4 volt. That means across these two, that 4 volt need to be dropped. And if that 4 volt is getting dropped across these two, across this one it need to be 2, and here this is supposed to be 2. Now 2 plus 2, 4. Okay, 4 plus 4, 8 plus 4, it is 12. I believe it makes sense, right? Yes. In that condition, what is going to be the current flowing through the circuit? Of course, the current flowing through this circuit, it can be calculated as I equals, okay, what is the voltage here? V, and resistance is R. Now the voltage that is dropped over this one, or you can go for this, both are the same only. Voltage is 2. Alright, and the resistance is how much? Resistance is coming as 200. Okay, so you know that this is going to be what? 1 upon 100, or if I multiply with 10 and divide by 10, I can say that this is going to be 10 milliampere. The current is going to be what? 10 milliampere. Is that fine? What they are looking forward to is, what is the power that is getting dissipated across the Zener diode. So the power across Zener diode, we will calculate it as voltage across Zener diode. Okay, because we know that P is equal to what? V into I. So voltage across Zener diode multiplied by the current. So the current which is supposed to flow across this one is the same thing. What it is? 10. Okay, so I can mark it as I, which is common for all. Now voltage across Zener diode was what? It was 4 volt. Okay, it was what? 4 volt. 4 multiplied by, what was the current here? It was 10 milliampere. So 10 into 10 to the power minus of 3. So here this is what? This is supposed to be 40 milliwatt. So the power which is getting dissipated across one Zener diode is how much? 40 milliwatt. Is that okay? Now let's move to the next, that is question number 4. Question 4 says, the logic circuit shown above is equivalent to. That means for this one, out of this 4, which could be the perfect match? Okay. Now in this question, I believe you can spot what is the difference between 2 and 4. The difference between 2 and 4 is, what is the output here? Inverse that is the output here. Okay, so that must be kept in mind first of all. And after that, of course, we need to check the like what could be the identical thing possible here. So let me start with the first one. I mean, that is what is given to us. Okay, so here, if let me go to a fresh page to deal with this. So let me consider the truth table for the gate what's given here. All right, so it's something like this. I'm having A and I'm having B here, followed by a NOT gate. All right, and after that it's fed to an OR gate. So I'm going for A, and after that I'm having B, and after that I'm having what? B bar. All right, and after that what it is? After that it is A plus B bar, and here this is C. C is equal to A plus B bar. That's equal to C, and after that it is C bar. Okay, now here this is C bar. All right, so let me consider the inputs. 1, 2, 3 and 4. 0, 0, 0, 1, 1, 0, 1, 1. B bar means 1, 0, 1, 0. Next is A plus B bar. I repeat, it is A plus B bar. So A plus B bar means here it is supposed to be 1 and here it is supposed to be A plus B bar, here it is supposed to be 0 and here it is supposed to be 1 and here it is supposed to be 1. So it's 1, 0, 1, 1. Okay, and inverse of this, it's supposed to be what? 0, 1, 0, 0. 0, 1, 0, 0. Alright, so this is my final output. And now let me consider gate number 1. Okay, for gate number 1, here I have got what? A. So I am considering that A. Here this is B. Alright, so here this B. And here it is what? B bar. I am considering that. And now here it's supposed to be what? A dot B bar. So I am going to consider as C, that's equal to A dot B bar. It's C here. And here it's going to be what? C bar. Okay. Now the inputs. One, 2, 3, 4. 0, 0, 0, 1, 1, 0, 1, 1. B bar. B bar means it's 1, 0, 1, 0. Alright. Next it is what? A dot B bar. Okay. It's A dot B bar. So A dot B bar, and you must understand here what this was. It was A plus B bar. Okay. So you might have got the conclusion. Fine. So it's A dot B bar. A dot B bar means here this is supposed to be 0 and here it is supposed to be 0 and here it is supposed to be 1 and here it is supposed to be 0. Alright, and here this is 1, 1, 0, 1. What it was? 0, 1, 0, 0. Alright, so you might have, I told you, no, here itself we can log, it's not going to be the same. Fine. Alright, now come to this. Come to this. Here I am having, of course, A is there, B is there. Okay. Then we have got what? Here this is going to be C is equal to what? A plus B, and while coming here it's going to be C bar. Okay. Yes. So now let's get the truth table for this. 1, 2, 3, 4. 0, 0, 0, 1, 1, 0, 1, 1. Okay, and it is A plus B. So since it is A plus B, this is supposed to be 0 and rest all is going to be 1. Okay, and inverse of this, here this is going to be what? 1, 0, 0, 0. So this is not the answer. This is also not the answer. Okay, now let's come to this. Let's come to this one. Okay, that means gate number 2. Again I have got A here, and while reaching here it is A bar. Now I have got B here, and while reaching here it is what? C equals A bar dot B. Okay, A bar dot B, that is output here, and after that it is C bar. Okay, fine. Are you getting me? Now, have you checked this? This was our main. This was, as per the question, this was our final option, like A plus B bar equal to C, and here it is coming as C bar, isn't it? Now here what we are getting, it is A bar dot B plus C. Okay, yes. Now let's go for the possibilities of truth table here. 1, 2, 3, 4. Again 0, 0 0 0 1 1 0 1 1 inputs. Now the inverse of this, that is 1 1 0 0. Okay, now have a look. We need a bar dot b, a bar dot b, a bar dot b. This is supposed to be 1 and rest all supposed to be 0. And the inverse of this, here this is 1 0 1 1. Are you getting me? Here I was having 0, it's 1, it's 1, it is 0 0 1 0 1. And have a look. This one was 0 1 0 0, isn't it? Here we got it as what? 1 0 1 0 1 1. All right. Now I told you just inverse of this, that is supposed to be the next. In the beginning itself I started with this, isn't it? That means these two are supposed to be inverse of each other. All right. That means what it is supposed to be? It's supposed to be this one. Are you getting my point or what? Fine. And there, what it is? 0 1 0 0. And what it was here? 0 1 0 0. Are you able to identify the difference? Okay. That means which should be the answer? Option 4 should be the correct answer. Okay. Now here I have utilized this question to perfectly teach you how to create the truth table for a given circuit diagram also. And of course, in the beginning itself I told you how to spot the difference. That means like these two differences are here, that means that comparison already appears here. Personally, if I was targeting on how to solve this question with shortest time, obviously I should have start with this one because it seems it's comparable. So there is chances of answer to be these two options. It means very close chance is there. And of course by in this case, by identifying, just by creating the truth table for these values, like once we are having this particular thing over here, see what it was a plus b bar equal to c. Okay, so since it was a plus b bar equal to c, that means this part a plus b, so that cannot be an answer, isn't it? So in that way also, like just by identifying the operations here also you can get to the answer. But I told you, since we are having a limited session related to the logic gates, that's why more I want to focus on how to perfectly create the truth table, because there might be questions on identifying the truth table also. Okay, so I think my intent is clear. Now let me take you to the next, that is question number 5. Question number 5 says, in connection with the circuit drawn below, the value of current flowing through 2 kilo ohm resistor is equal to dash times 10 to power minus of 4. Okay, dash time 10 to power minus of 4. So we need to identify what is the current flowing through 2 kilo ohm resistance. Okay, so here is that 2 kilo ohm resistance, 2 kilo ohm, and parallel to this I am having a Zener diode connected. All right, and breakdown voltage is what? 5 volt. And after that we have a 1 kilo ohm resistance, and this setup is being driven by a 10 volt voltage source. All right, now the important part here is the potential drop across this one is what? 5 volt. So here also the potential difference is supposed to be what? 5 volt. Okay, now out of 10, 5 is getting dropped here. All right, what is left? Left with is 5 volt only. You're getting my point? So we are left with what? 5 volt only here, and here it is 5. Now obviously, to identify the current flowing through this one, that is what they are asking for, is current flowing through 2 ohm resistor, 2 kilo ohm resistance. So current flowing through 2 kilo ohm resistance, I through 2 kilo ohm, that is supposed to be, what is the potential drop? It is 5 volt. 5 all divided by, what is the resistance here? Resistance here is 2 into 10 to power 3. This will go to the top. So here this is supposed to be 5 by 2 into 10 to power minus of 3. 5 by 2 is 2.5. So it's going to be 2.5 into 10 to power minus of 3 ampere. What we want is in terms of 10 to power minus 4. So I am going to mark it as 25 into 10 to power minus of 4 ampere. So the current flowing through this particular part, that is equal to how much? 25 into 10 to power minus of 3. It's over here. Now, I want to take you a bit more in depth to this. Okay, the question is over here, you must understand. But I would like to ask you one more point here. What is the current flowing through this 1 kilo ohm resistor? See, have a look. There, if I focus my attention over here, what is the potential drop? It is 5 volt. What is the resistance here? It's 1000. Isn't it? So I can say this is 5 into 10 to power minus of 3 ampere, or comparing with the power here, I can say that 50 into 10 to power minus of 4 ampere current is flowing through this. So the main current coming, it is 50 into 10 to power minus of 4. Out of that, 25 into 10 to power minus of 4 is 25 into 10 to the power minus of 4 is coming here, which means the remaining, that is 25 into 10 to the power minus of 4 ampere should be the current flowing through what? The Zener diode. Okay, now what could be the resistance offered by this Zener diode? Of course, R is equal to V by I, or how to calculate the power dissipated? It is V into I. So that type of question also we can expect. So it's not like I just calculate the current over here, that exactly the same current is flowing in this way. No, it was 15 to 10 to the power minus 4, which was drawn from the cell. It reaches here, that's divided into 2 parts, 25 each, 25 into 10 to the power minus 4 as well as 25 into 10 to the power minus 4, and combined, getting combined over here, and it's getting added up to 50 into 10 to the power minus 4 again, and making the circuit complete. All right, is that okay? Yes. Now let's move to the next, that is question number 6. Question number 6 says, draw the output signal Y in the given combination of gate. Okay. Yes, in this condition, let's first of all create the truth table. Okay, I am having A here, so that A is getting fed to this. So here this is going to be what? A only. Okay, and I am having B here, B is fed here, and since I am having A here, I am expecting A bar here. Okay, so creating the truth table, I need A, I need B, I need A bar, isn't it? And here I am going to have what? C, which is going to be A bar plus B. Okay, so I am going to have C, which is equal to A bar plus B, A bar plus B, that is C, and finally I am going to have C bar here. So I will be having that C bar. All right. So here these are the operations that is taking place. Now I need to give the values. Okay. So I am having the time interval 0 to 1 here first. Okay. So let me create the space for time interval. It is 0 to 1. All right. And after that 0 to 1. And after that 1 to 2. Okay. Then 2 to 3. It's 2 to 3. Then 3 to 4. Then 4 to 5. 4 to 5. Okay. 3 to 4 and 4 to 5. That's what we have. Now, 0 to 1, 0 to 1, I have got 1 0. For A it is 1, for B it is 0. And so 0 to 1 it is 1 0, 1 to 2 it is 1 1, it's 1 1. Now 2 to 3 it is 0 0, it's 0 0. Then 3 to 4 it is 1 1, it's 1 1. And 4 to 5 it is 1 0, it's 1 0. That means what I mean to say is the value which is high I take it as 1, the value which is low that I am taking it as 0. I hope you got the logic. Yes, now let me do the operations. So it's A bar first, so it need to be 0 0 1 0 0. Next is C, which is A bar plus B. It's A bar plus B. A bar plus B means here is 0 plus 0 0, 1 plus 0 1, 0 plus 1 it is 1, 1 plus 0 it is 1, 0 plus 0 it is 0. Okay, next is Z bar, which is 1 0 0 0 1. So it need to be 1 0 0 0. So here this is 1 0 0 0 1. So with the final output, this waveform perfectly match, which means my correct answer is going to be option 4. Alright. Now let's move to the next, that is question number 7. Question number 7 says the value of power dissipated across the Zener diode whose breakdown voltage is 15 volt connected in the circuit as shown in the figure is x into 10 to power minus 1 watt. I repeat, it is x into 10 to power minus 1 watt. Then the value of x to the nearest integer is, that is the question. So here I am having 22 volt input, okay, and this is a 22 volt input, followed by that I am having a 35 ohm resistance here. This is the input, 22 volt input, alright, and here is that Zener diode whose breakdown voltage is 15 volt, alright, and followed by that we have got a 90 ohm resistance. Alright, so out of 22, 15 is getting dropped across here, which means across this it need to be 15 volt. Okay, so out of 22, 15 is getting dropped here. So how much is left? How much is left? We are left with only 7 volt. So that 7 volt need to be the drop across here. Is that fine? Okay, now what is the current flowing through this then? So since I know the potential drop as 7 volt, so the current flowing through 35 ohm, current flowing through 35 ohm resistance is I is equal to V, that is 7 upon R, that is 35. 35 can be written as what? 7 into 5. 7 and 7 will cancel. Here this is supposed to be what? 1 upon 5, isn't it? 1 upon 5 is the current flowing, or you can mark it as 0.2 ampere. Alright, so 0.2 ampere current is coming over there. Now, what's the current flowing through this one? So current flowing through 90 ohm resistance. Okay, I through 90 ohm resistance. I through 90 can be marked as what? Voltage drop over here is 15, all divided by 90. 90 can be written as 15 into 6. This one and this one will cancel each other. It's supposed to be 1 by 6. Okay, now have a look. The current coming here, it was 1 by 5, and the current flowing here, it is what? 1 by 6. Now, what's supposed to be the current flowing here? It is supposed to be 1 by 5 minus of 1 by 6. Alright, and here this is going to be 1 upon 30. 1 by 5 was coming here. Out of that, 1 by 6 is going there. So what is left? 1 by 30 is left. Here this is going to be 6 minus 5, that is 1, and here this is 60. So 1 by 30 is the current flowing here. Now the point is, what is the power getting dissipated across this? We all know that power across the Zener diode, that is supposed to be the voltage, that is 15 into the current, that is 1 by 30. Alright, clear? So this is 1 by 2. Alright, so what this is supposed to be? Here this is supposed to be 0.5, 0.5, and we have it as 5 into 10 to power minus 1. That means the answer is 5 into 10 to power minus of 1 watt. That means X is supposed to be 5 here. That's the final answer. Now let's move to the next, that is question number 8. The question says, which one of the following will be the output of the given circuit? Okay, now let's see what is the output here. I am having A here, so that is A, and I am having B here. B is going like this, so I need B as well. So here it's A coming in, and this is C equals A plus B. So I need that C equals to A plus B. Okay, so here it is C, and this is what? B only, and what I have here, it is D, that is A dot B. So I am having D, that is A dot B. Now here this is supposed to be D dash, so I am going to have D dash. Now here this is D dash, and here this is C, and now here this is going to be what? D dash dot C. Okay, so it's D dash dot C. So operations are clear. Now let me go for the truth table. 1, 2, 3, 4. Okay, 0, 0, 0, 1, 1, 0, 1, 1. It's A plus B now. So for A plus B, this is supposed to be 0, rest all is supposed to be 1. And for A dot B, this is supposed to be 1, and the rest all is supposed to be 0. Isn't it? And next is D dash, inverse of this, 1, 1, 1, 0. Alright, now the dot of A dash dot C. A dash dot C. So here this is 0, 1, that is supposed to be 0, 1, 1, it's supposed to be 1, 1, 1, that is supposed to be 1, 1, 0, it's supposed to be 0. Okay, so what we have is 0, 1, 1, 0. And here I am having 0, 0, and here it is 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. Here I would like to take you the attention to X AND gate. For X AND, if both the inputs are same, like for example, here this is A, B, okay, 0, 0, 0, 1, 1, 0, 1, 1. A and B are having same input, so it's supposed to be 1 here. Again, A and B having same input, it's supposed to be 1 here, rest. So this is X AND, and XOR is inverse of this, that is 0, 1, 1, 0, and I am having 0, 1, 1, 0. That means this is XOR gate. Option 4 need to be correct answer here. Alright, next one is question number 9. Question number 9 says, For the forward biased diode characteristics shown in the figure, the dynamic resistance ID equal to 3 ampere will be. So here this is 3 ampere. Okay, now across this, around this, if I want to identify the change in voltage, so change in voltage near 3 ampere current, that is taking place as what? 0.6, 0.6, no, it is 0.65 to 0.75. It's 0.65 to 0.75. So delta V, that is equal to 0.65 to 0.75, that means 0.75 minus 0.65. Basically, this is equal to 0.10, 0.1, isn't it? Yes. Now, what about delta I here? Delta I can be marked as, here the corresponding value got changed from, 1 to 4. Here this is 1 and here this is 4. So delta I is 4 ampere. Not 4 ampere, 4 milliampere. It's 4 milliampere. We need the dynamic resistance. So the dynamic resistance R, that is supposed to be delta V. Delta V is 0.10, okay, upon 4 milliampere. So 4 milli means this will go to the top. Here this is 10 to the power minus 3 will go to the top. It's going to be 10 to the power 3 here. Okay, and I am going to write this as 1 by 4. No need to run like that. Here this is 0.1 into 10 to the power 3, isn't it? 0.1 into 10 to the power 3, definitely this can be written as what? 100 by 4. 100 by 4 basically. So it's what? It is 25 ohm. So the dynamic resistance here for the given circuit, once the current was 3 milliampere is 25 ohm. I repeat what I did. The current which was told to me to identify the dynamic resistance was 3 milliampere. So I spotted that, and across that, a perfect variation that I can identify is the variation from 1 to 5. Okay, around 3, the variation can be spotted from 1 to 5. So I identify perfectly a calculatable variation of current, and I identified the corresponding change in voltage around 3 ampere. 3 milliampere, I don't know why I am saying 3 milliampere, because I can see that 3 here all the time, isn't it? That's why. So around 3 milliampere, I identify the voltage change as well as current change, and delta V upon delta I got the value as what? The dynamic resistance here. That is what actually happened here. Okay. Now let's move to the next. That is, consider a situation in which reverse biased current of a particular PN junction increased when it is exposed to a light of wavelength 621 nanometer. So wavelength lambda is equal to 621 nanometer. That is 6 to 1 into 10 to the power minus of 9 meters. Okay, during this process, the enhancement in the carrier concentration take place due to generation of whole electron pair. Then the value of band gap is, that is the question. We all know that E is equal to HC by lambda. Okay, fine. Here lambda is given 621. Okay, so the wavelength is less than or equal to 621. Okay, fine. So in that condition, the energy value, that is what we need to find out. Okay, then capital E, that's equal to, if I want to write the value of H in terms of electron volt second, it's supposed to be 4.13 into 10 to the power minus of 15 electron volt second into C, that is 3 into 10 to power 8 all divided by, here the value is given as what? 621 nanometers. 621 into 10 to power minus of 9. Okay, here I am going to mark it as 413 into 10 to power minus of 17 into 3 into 10 to power 8 into 10 to power 9 all divided by 6 to 1. Alright. So now here have a look. Here this is 8 plus 9, 17 plus 17 minus 17. They will cancel each other. Now I am left with 413 into 3 all divided by 6 to 1. Let me go for this. 413 into 3. 3 3s are 9, 3 1s are 3 and 4 3s are 12. 1 2 3 9. It's 1 2 3 9 all divided by 6 21. Approximately it should be 2 electron volt. No doubt at all. Option 1 should be the correct answer. Next is question number 11. The question says, in a semiconductor, the number density of intrinsic charge carriers at 27 degrees Celsius is 1.5 into 10 to power 6. So, the density of intrinsic charge carriers is 1.5 into 10 to power 16 per meter cube. Okay, at 27 degrees Celsius. If the semiconductors is doped with impurity atom such that the whole density increases to 4.5 into 10 to power 22. Okay, then the electron density in the doped conductor is dash times 10 to power 9. Then what could be the perfect value here? That is a question. We know the standard relation n suffix I, that is supposed to be Ne into Nh. We know the, Ni square. Ni square equal to N into Nh. And what is Ni square? Ni square is going to be 1.5 into 1.5 into 10 to power 32. That is supposed to be, we need the electron density, isn't it? That is supposed to be Nh. What is the value of Nh? The value of Nh is given as 4.5 into 10 to power 22 multiplied by n suffix e, and we need n suffix e. So here n suffix e is now going to be, of course this will go to the left, so it's 1.5 into 10 to power 32 into 1.5 into 10 to power minus of 22 all divided by 4.5 can be written as 3 into 1.5. This 1.5 and this 1.5 definitely is going to cancel. Alright. So here we know that this will cancel, will leave 2 here. Alright. 3 is 1.5 into 2, 1.5 and 1.5 will cancel. Now here this is supposed to be, now what about this? It will leave 10 on the top, 10 to power 10 all divided by 2. 1 by 2 is 0.5. So here you are getting it as 0.5 into 10 to power 10, or this is supposed to be 5 into 10 to power 9 per meter cube. Okay. Now let's move to the next, that is question number 12. A Zener diode of power rating 2 watt is to be used as a voltage regulator. Okay. If the Zener diode has a breakdown voltage of 10 volt and it has to regulate a fluctuation between 6 volt to 14 volt, the value of Rs for safe operation should be. Okay. So here the circuit is expecting a maximum of 14 volt. Okay, expecting a maximum of 14 volt. Here this is RS, and we are having a Zener diode here. Okay, and here this is the point across which we prefer to maintain a voltage regulation. All right. So here the voltage, the Zener, the breakdown voltage is supposed to be what? 10 volt here. It's supposed to be 10 volt. So have a look. Here I am having 14 volt. Maximum we can have 10 volt here. So the leftover is what? 4. So 4 volt we are expecting here. Okay, we are expecting 4 volt here. Now you must understand the power rating of this particular Zener diode is what? 2 watt. Now we know that power P, that is supposed to be V into I. Okay, fine. What is V here? V is supposed to be 10 and power is how much? 2. So the permissible current, it is I. So I is equal to what? 2 by 10. Okay, that is 0.2 ampere. Fine. That means through here, what should be the current flowing? It should be 0.2 ampere flowing. Are you getting me what? Now, we need to have 0.2 ampere current flowing here, current flowing through this one, provided 4 volt is the potential drop across RS. So in that condition, V over RS is 4, that is equal to current flowing is 2 by 10. Okay, and the resistance is what? Resistance is capital R. This one and this one will be cancelled. It's going to be 2. Now R is supposed to be what? 20 ohm. That means while this Zener diode is regulating 10 volt, the current flowing through this is going to be 0.2. The same current will be coming over here. At that time, here this will be having, this need to accommodate 4 volt, and at that condition, in order to accommodate 4 volt, the resistance need to be maintained as what? 20 ohm, and that is what they are asking. So the answer here, this is 20 ohm. Now let's move to the next, that is question number 13. Question number 13 says, in the given figure, each diode has a forward bias resistance of 30 ohm and infinite resistance in reverse bias. The current I1 will be. See, dear students, this is negative and this is positive, and here this is negative and this is positive, here this is negative, this is positive, here this is negative, this is positive. So for me, this is reverse biased, here this is positive, right? So P region connected to P region. I think I marked this as wrong. This is positive, this is negative. Just a minute. Positive, negative, negative, positive, positive, negative, positive, negative. Okay. So for me, this is reverse biased. Here this is forward biased. Here this is forward biased. Okay. So once I redraw the circuit, I am going to draw it like this. Here this is the battery. Resistance, it is 20 here, and this is offering 200 volt potential difference. Now this is not part of our circuit because that is offering infinite resistance, so we cannot consider this part. This entire part is not in our circuit. Okay. Now here this offers a resistance of 30 ohm. So 30 plus 130, it is 160. So I need to mark that 160 there. And here also 30 plus 130, that's going to be 160 there. Alright. 160 parallel 160, it should be 80. Okay, so I am going to draw the circuit like this. It's 80 and here I have got 20 volt, sorry 200 volt, and I am having 20 resistance. So altogether this is offering 100 resistance, as total resistance is coming as what? 100. Now the question is, what is the current? So the current I1, that is the potential difference offered, it is 200, and what is the total resistance? It's 100. The answer need to be 2 ampere, that means option 3 is going to be my correct answer. Okay, yes. Now let's move to the next, that is question number 14. Question number 14 says, the IV characteristics of a PN junction diode in forward bias is shown in the figure. Okay, the ratio of dynamic resistance corresponding to forward bias voltage of 2 volt and 4 volt is, here this is 2 volt and here this is 4 volt. So let me take the variation at 2. I can support a variation from 2 to 2.1. So delta V at 2 ampere, sorry 2 volt. Okay, that is coming as how much? 0.1. Okay, now delta V at 4, that is coming as how much? 4 to 4.2, that is 0.2. Okay, now delta I at 2, it's coming as 5 to 10, that is 5 ampere, and delta I at 4 volt, that was coming as 200 to 250, that is 50, and we need the ratio of 2 to 4, 2 to 4. Okay, so dynamic resistance at 2 upon dynamic resistance at 4, that is now going to be, R is V by I, V is 0.1 upon delta V is 0.1 upon I was 5, all divided by 4. 4 volt, delta V was 0.2 and current was how much? It was 50. So I am going to mark this as 0.1 upon 5 into 0.2 into 50. Okay, so of course here this is going to be what? 2, and here this is going to be what? 10. So the answer is 10 by 2, which is supposed to be 5. That means option B should be the correct answer. And here comes the last question for this video. The question says, as per the given circuit, the value of current flowing through the battery will be. So here this is minus and here this is plus, and here this is minus, here this is plus, and here this is plus, here this is minus, and here this is minus, here this is plus. So here this is reverse biased, here this is forward biased, and here also it is forward biased, and there is no forward bias resistance as per the question. So we need to proceed with the given value of resistance only. So this particular part is no more going to be in my circuit because that is reverse biased. So once I redraw the circuit diagram, I have to draw it like this. Here this is minus plus, and here I am having 2 ohm resistance. 2 ohm resistance is there, and here I am having 16, 10 plus 6. I am having 16 ohm resistance here. So it's 16. Okay. Now here also it is what? 16. Here also it is what? 16, because I am having 6 here and I am having this in series, so that's going to be 16. Now it's 16 parallel 16, that is supposed to be 8, and I am having 10 volt potential drop over here. So this is going to be, the combination of this is going to offer what? 8 ohm resistance. So I will be redrawing the circuit like this. I will be redrawing it like this. Here this is 8, here this is 2, and here this is what? 10. So here this is what? 10. So the current flowing through this one is supposed to be 10 by 10, that is 1 ampere. Alright, so the current flowing through this one is supposed to be 1 ampere. So my dear students, that was all from my end for this video. See you in another video with the detailed discussion of PYQ from another chapter. Till then, bye bye and take care.